Very good evening a very good evening.
Very good evening, madam.
Today we all are here to learn something about mathematics, something about Geogebra. Right? The word itself is so interesting. Geogebra. That means amalgamation of geometry as well as algebra. Both are very interesting topics of mathematics, right? We have among us a very renowned and very young personality. Can Dr. Barve to please switch on his video? Dr. Barve, if you listen to me, I request you to please switch on your video. I think there is some net issue at sir's side. Just give us 2 minutes. We are contacting with him. Meanwhile, by the time sir comes, I request kindly switch on your videos. All math teachers over there, kindly switch on your videos. Oh, great. Now we can see. Yes, wow, math teachers can be so joyful, smiling. That's great to watch. So how many of you are already using GeoGebra? You can just raise your hands and let us know. Oh, Archana madam is using. And Renuka madam is also using. Vimla ma'am is also using. Who else? Okay, many of you are already using. So you have your question. You have your question banks ready with you, right? Those who are already using GeoGebra. Great. Okay. So how the session will go today? I'm just waiting for sir to join. He had joined us. Some net issue, so he'll be joining back again. So all of you have downloaded the GeoGebra Classic in your systems? Downloaded. Oh.
Yes, madam.
Okay. And some of you experimented also? Huh? Yes. Many of you. Manjunath sir has experimented. Chita ma'am has experimented. Oh, good. Like children, no?
Good afternoon, madam.
Good evening, sir. Abdul sir. Yes, sir.
Yes. Actually, we are not unable to download that app when I'm trying through Android.
Okay.
I don't find that app. That is
okay. Okay. We will ask the expert this question also. Anyhow, in laptops, yes, all of us were able to do it. But we asked whether it is possible in Android or not. I think sir is there with us. Dr. Barve.
Yes. Even in internet, I tried, madam.
Oh, okay. Abdul sir, we will definitely ask sir. Now, sir is here. So I'll just formally introduce. I don't think I have that capability to introduce such a great personality among us, but still I'll try a little bit in brief. Of course, his persona speaks by. So we have the honor of having Dr. Vasant Barve with us. So Smart Cerebrum is feeling fortunate to have such a personality among us, who's the youngest person among us. You will understand why I'm saying so, because his energy levels we all cannot match. And I'm saying that truthfully. So Dr. Barve is a renowned mathematician. He's IITian, and I don't know, I could know his degrees he has done from IIT. So he has immense experience in mathematics, also in science, and he has published papers internationally and national level both. And he keeps on reinventing himself how to make the modules easy for teachers and students as well. And not only in mathematics, also in science. He has his own YouTube presence also, where he is teaching all these tricks to our youngsters as well as teachers. So not taking much time, Dr. Vasant sir, all are waiting to listen from you and learn from you the Geogebra today. Over to you, sir. Sir, you are on mute. Kindly unmute yourself. Dr. Vasant, sir, you are on unmute.
Yes, I could do that.
Oh, thank you, sir. Please
Now,
go ahead.
yes. Now we'll have this. Are you seeing the GeoGebra screen now?
No, sir.
No, sir, I think we were able to see, but again it went off.
Just a minute. Now, from where I have to get it? My God. Is it minimized video? Is the screen now there? No?
No, sir. No, sir.
No, sir, no, sir. So
Not
kindly.
yet. Is it now? Share.
Sir.
Now it's starting. Sir.
Okay,
Coming,
thank
sir.
you.
It's
thank you.
coming.
We old people, we are not so much in technology.
No, sir, your technology we cannot match.
Okay, so let me start my lecture by lighting the lamp. So here, actually, I would have asked Guru to do this. Can he click this thing from
Yes.
there?
You want him to do what, sir, please?
No, this small arrow is to be clicked.
Yes, sir, we can see the arrow there, input.
Yeah, please do it.
No, sir, we cannot
No,
have.
then I will do it for you.
Yes, sir.
Okay, so Dr. Alka is clicking this, and see now the lamps will light.
Wow, sir.
I'm not hearing any clapping. Okay, so now here what I have done is I have taken a pentagon. On the side of pentagon, I have put some semicircles. In that semicircle, these two semicircles are there, and there is a small triangle here. I will show you the better view of the lamp. I don't know why this is not changing. Number should change. Okay. Right. So now see this lamp. See the beauty of the lamp now. Now I'll
Wow.
show you the algebra of this.
Fast in technology, sir.
I'll show you the algebra. See, this is the algebra. Okay. So each of these have some equation here. So we'll go ahead and see one by one how these things are done. Okay. So I will take a blank screen and start. Now, because of this online thing, it has become a little bit of slow. Otherwise, it is quite fast software. It's a very small utility, Geogebra, can be downloaded by anybody. Okay. Now, this Geogebra is a powerful tool to experiment with numerical and symbolic manipulation in the field of mathematics and science. This is a freeware. It was developed by Marcus Honewarter around 2001, and over the year it is growing. Maybe something is added because it is a freeware. Okay. Now I'll thank Venkat Subbarao and start with it. Am I getting it clear?
Yes, sir.
Now,
Sir, a
yeah.
little louder, sir.
Okay. Now this is the Cartesian grid.
Yes, sir. We can hear you.
Cartesian grid. Now, in this Cartesian grid, it is possible for me to locate some point.
Voice.
As soon as I put point here, in geometry, the algebra appears. You can see A, 3, 1. Okay. So this algebra automatically appears there. Now, if I want that this 3, 1 also should be here, then what I have to do is I have to go to properties, and there, instead of symbol, we should also get the value. See here, name and value if I put, then you will see that you get this 3.1. Okay. So point can be put like this. Now, another point if I put, then I can join this by a segment. Right. So immediately the length of the segment will come here. Right. So this is how you can play around. Now, if you want a line here, then we have got utility for lines here, line. Then you connect these points and immediately you have got the equation for this line. Okay. So this is how it's possible for you to take care of the geometry. Now let me show a small thing. Maybe at 5th or 6th standard, we are going to teach children. So I am going to show you small application which teacher can use in the class. Now I take this triangle application, I put it at some points. So immediately you'll see that A, B, C points are shown, then the length of the segments are shown, and the area is shown. You can clearly see the area here. The base is 4, height is 3. So 3 into t by 12 is 6. Now what I am trying to show them, my students, that the area does not change if I keep the height same and the base same, right? So for that, what I do is I select this point C and move this point horizontally. You'll see that wherever I go, the area here remains fixed, 6. Now this can also be done by on board. but it will not be as effective as is seen right now. See, so children enjoy as well as learn the thing. Now, supposing then we in sixth standard we have some problems wherein you have a plot where you have to pave the plot, what is the cost? You have to put a compound to the plot, what is the cost? So compound cost will depend on perimeter, whereas the paving cost will depend on the area, or lawn cost will depend on the area. So area here is remaining constant, but the perimeter is changing. So let us see how perimeter is changing. So for that, we can add these three, or you have a function for perimeter. Okay. So you have a function for perimeter. So enter that and say name of the polygon as T1. Okay, and enter. So I have got this perimeter here. And now again, if I pick this point C and move, you'll see that the perimeter is continuously changing. Now we can ask students as to at what point or where I should locate C so that I will get the minimum perimeter for the same area. Okay, some smart student will tell you the answer, but now let us demonstrate to them this particular answer. So for that, what we do is we move this point C and ask our student to watch that this value D. Okay, so it is decreasing continuously. Okay, and at some point that value decrement will stop, say 11.23, 11.22, 21, 21, 21. So at three places, I got 11.21. So mid of that would be the minimum. Okay, but before that, I will show you that it is possible for me to change this rounding and show them clearly that it does get to a minimum here. Okay, see this, right? So we have got minimum here. And now immediately you will see that these two sides are identical. That means this particular triangle is an isosceles triangle. And moreover, if I move this up and down, then maybe that for equilateral triangle for the same area, you'll get minimum, this thing. So this is how it is useful for the teachers to see this. Now, if someone wants to plot a graph of this perimeter, it is possible. Okay. So for that, this area is 6 here. I mean, sorry, perimeter is 11. So it may go outside. I can zoom in. Okay. I can zoom in like this. Okay. And now we want to plot this point. Okay. And let us plot this point on top of P so that we'll see how the variation of perimeter is there with the location of C. Okay. So what we do is we define some point D such that the x coordinate of that is going to be at C and its y coordinate is going to be the value of D. You see you got a point there. Okay. Now what we do is we move this point C and see how this D is changing. See the D is changing. Okay. Now we want to see, how D is changing. What is the variation of that? So here there is a facility that we get trace of that. So now if I change this point C, you will get a plot. You see, you get a beautiful plot. Now, if you don't want that trace, okay, supposing I don't want that trace, I have a facility of plotting locus. So I say point creating locus. Okay. So I have point D. Just a minute. Point creating locus D, and along with E. No, it doesn't allow me. If it is slider, you would have got that. By trace, you have got that locus here. So this is how it's possible for you to take care of the, the application. Okay, and you start at even 5th standard and continue to use this particular thing. Now, one or two interesting things I will show, or before that, I will show you how you are going to get to other coordinate system, right? Here you have Cartesian system. We'll see the other coordinate systems. So this I am removing. And then here you click here, go to graphics. And in graphics, we have grid here. Right now, I have chosen major and minor grid lines in Cartesian system. I can go to a polar system. Now, in polar system, you see this as if you are looking at Earth from the pole. Okay? And these lines, they are at 30 degrees. Now, here, if you want to put a point, it accepts both Cartesian as well as polar. So in polar, we put this point like, supposing I want the point at 8 and at place 60 degrees. That is pi by 3. Pi by 3. Okay. So here you have to put a semicolon for Cartesian. I'm sorry, for polar. So just see here that now this point is available at distance 8 and exactly at distance, at angle 60 degrees. So this is how it is possible for you to have data entry in polar coordinate system. There is one more coordinate system available. Sorry. Graphics. You to grid, go here and say isometric system. Now this isometric system does not allow you to have direct data entry in isometric system. Then let us see what is the use of this system. Okay. So this system is used here. It's possible for you to construct cuboids very easily. Okay. You can construct cuboids very easily. Let me show you that. So for that cuboid, what I do is I construct a face here. Then second face I take up. Third face I take up. You see, you have to come back to this starting point to complete the face. Right. So please see that on left-hand side, you have all the corners here. Okay. Then you have these quadrilaterals. Then you have these segments. Okay. Everything is here. And these areas also are available. Okay. Now, supposing I want to decorate this particular thing, then what I do is I right click this, go to object properties, I go to color. Maybe I like this color. So this, you can choose some shade here. Then second one, you again choose, let us say, the same color. You go here. Maybe I keep this little lighter. And the third one, let's say I make it a little darker so that I get little bit of 3D appearance. So this cuboid is ready. Now it's possible for I to take this cuboid and put it in document or whatever it is, wherever I want to use. So for that, first of all, I don't want these points to be seen here. So I say, don't show me the object. Then I go down, and to this, I want to say that I don't want to see a label. Okay. So now this cuboid is ready. I don't want to see the grid also. And I want some good background color. So go to graphics. You go down here, you got background color. Maybe I like this color. Now this has become slightly faint. So for that, what I have to do is, I have to pull that up above that particular level. So for that, I say, let this be layer 3. See now, we have got this picture. And then what you can do is, you can export this picture. Export. And you can get it this as PNG file, okay, and put it anywhere you like. Or you can take a snip tool and cut it here like this and take it anywhere you like. You can save this. Okay. So this is how this particular grid is useful. This isometric grid. Okay. Now here we have got one more module. It's a 3D module. Okay. So I will remove this particular picture. So view will go and we'll say 3D. Now here, standard RGB convention is being used. Okay, red, green, and blue, X, Y, and Z. And the madam, can I move this? Are you seeing this full, or you're seeing some faces here?
So we can three parts.
Can you?
Graphics. You can see all three.
Okay, done. Right. Now, see this. Okay. Now, supposing I want to show you some solid. Okay. The GeoGebra has included the 5 platonic shapes, the inbuilt functions to get 5 platonic shapes. I hope you know what is this platonic shape, right? Platonic shape is a shape which is formed by all identical regular polygons. So first platonic shape is tetrahedron, second one is cube, third one is octahedron, fourth one is dodecahedron, and last is the icosahedron. Okay, so let me show you here how I get the octahedron. Okay, so for that I go here and I just put octa. So I got this octahedron here. Okay, now I need to enter the starting point. And now, as I told you here, it is a Cartesian system. So I have got X, Y, and Z. So first point I take at the origin itself. So 0, 0, 0. Okay. So this is the first point. And then second point I take is maybe on the x-axis itself. So 1, 0, 0. Okay, so this is my second point. And I connect this. See, immediately I get this octahedron. Right. Now, if you want the net for this, in mathematics, net is defined as the paper required to make this object. That is known as net. And in engineering, we call that as development drawing. Okay. So let us see this net. So before I put this net, I need a variable. Okay. So I click here. I take this variable, put it here. And this variable should be from 0 to 1. Okay, so I got this variable here. Now I say, please show me the net. So I say N-E-T, net. Okay. It is asking me as to what polyhedra you have. So I have got the name of the polyhedra here is A, and this number is B. So you'll see that immediately we get here this particular paper required. See, 1, 2, 3, 4, 5, 6, 7, and 8 triangles make octahedron. So this is the net and this is the solid. Now let me decorate this a bit. So this octahedron, I somehow like this magenta color. I increase the opacity. And for the net, let me say I like this blue color. So I got this solid as well as the net. Now these points, I don't want them to see. So I say that please don't show me the points. Okay. And these edges, okay. Now edges, I want that edges should be seen, but I don't want the label. So I don't want the name. So name should be value, name and value, value only, caption and value. What has happened? Don't want name. Okay. We'll do here name and value. Yes, the name has gone. Values also I don't want. Okay, right. And I want this to be in different color. So I want it in yellow color. Okay. Now it is ready. Now what we can do is here we click here, we click here, and we can rotate this. And in addition, what I can do is I can show you how this paper gets wrapped.
Wow.
See, when it closes, it looks like a flower. You know? When it just closing, just see. Somewhere here. Right. So all the solids, that means these 5 platonic solids, they have inbuilt functions for this. Okay. Then let me see how this is going to be useful to us, right? So this I'll take. Right. So we have gone back to our original view. Right. So one more effective tool I will show you is the reflection tool. And this reflection tool is used quite useful in optics and in geometry for seeing the similarity, etc. So for that again I will show you a small thing which I normally entertain children with. Let us say I take this triangle, okay, and I decorate this triangle. Right. And now I reflect this triangle. Okay. So for reflection, I have a tool here. So reflect. I pick up this triangle and reflect it about y-axis. I got the reflection. Then I reflect this about x-axis. And then this image I reflect about y-axis or this about x-axis, whichever way you like. So I pick this up and reflect about y. Okay, right. Now I want to say that these are the 4 limbs of a person. So I show a small head of that person. Right. And let us say that he's wearing some dress. Right. That dress I can give some color, maybe blue. And then I don't want to see so many points unnecessary they are there. Right. And these segment labels I don't want. Right. Now I just pick this point C and move this. Okay. So we have here a person doing some exercise. Okay. And the young children, they love this. Okay. So this is how this reflection tool is there. Okay. Now, something useful to you. I made this thing. I think, I don't know whether it is the 9th standard or 10th standard, where this question is being asked as to what type of arrangement, when folded, will make a cube. Okay. Anybody remembers which class it is there? This one?
8th one, sir. 8th class.
8th class. Okay. Okay. No problem. So see, I have taken this particular thing. These 6 squares should make a cube, right? And see whether this arrangement makes it. So what I am supposed to do is, we just pick it up here and move this. Okay. And simultaneously, if I keep this rotating, maybe so you get better view. Okay. So it's possible for you to take care of this particular thing. You can make many such things. It's not difficult at all in GeoGebra, okay, to make these animations. Okay. So any of these arrangements is possible for us to take care of. Okay. I don't know where I've kept the choice. In somewhere, and my screen has become quite small here. Somewhere I kept the choice as to which one I should take. Okay. Is it here? No. Or is I click here? Choice, where somewhere I kept the choice. I think this here only. I make this, no. But I have that choice here. My screen has become small, so I don't see where I've kept that exactly. Yeah. No. Somewhere I would have put that N, and then when I change that N, you will get all these different kinds of arrangements. Okay. Somehow, I've not run this for quite some time. One will get the net by pasting command in the command line. Okay, achha. Right. So I have to edit, copy this, and put it in the command line. Okay. Enter. Net, okay, delete. Right. So now you'll see that you've got this another arrangement. And here again, I can change this and continue and animate this. So any of these arrangements can be shown to the students. Okay. It's possible for you to do that. Okay. These points I can hide. So this is one of the things. Now, one ninth standard application I will show you.
Sir?
Yes, please.
Sir.
You want anything specific?
Yeah. Sir, namaste, sir.
Huh.
Sir, actually, we are getting all the messages that we all are really mesmerized to see that mathematics can also be like this. I was just sharing with Dr. Elka now. Even forget about the higher classes, even the dancing and jumping of geometrical shapes can be used even for primary classes also. So
Yes,
children
yes, yes.
understand how beautiful mathematics is.
Correct,
Okay,
correct.
and you can make geometrical shapes to dance and jump. Sir, I
Yeah.
have one request.
Yes,
Can
please.
I ask you now, sir?
Yeah, yeah.
Yeah. So one request that I should tell you, normally we allow only 30 people. That's what we said. But for this session, we had to allow many people, more than 30, though we restricted.
Okay.
Still, we are getting the mails that we want to attend the session. And
Yes, sir.
many of them are watching on YouTube also, live.
Right,
So
right.
my request is, sir, we all are teachers here, mathematics teachers.
Correct.
And it is so nice to see that mathematics teachers are enjoying mathematics. Okay.
Right, right.
Because mathematics teachers normally, if we enjoy, then naturally it goes to others. That's what, friends, I was telling. Dr. Barve, sir, is the youngest among all of us, actually, when it comes to mathematics. We can see his excitement and getting lost while explaining something, enjoying. That is beautifully well. Sir, my request is, as a master, you please give us some homework or some work now, so that we will try, because we all have downloaded GeoGebra and waiting now to do something. This is what is the excitement you created in us now. So if you can give us some small task to do, we will do it in our screen. And friends, we can also share your screen after creating. Can we do this for a moment? And then again, sir will explain other concepts. What do you say?
Yes. No problem.
No, sir. For teachers also. Teachers, what do you say? Shall we do some work and then sir explains, or before we do, sir, let him explain other concepts?
Right. Now I would give a simple task.
Yes, sir.
That construct a right angle triangle with sides 3 and 4. Right?
Sir, slowly, sir. We will write it down. 1 second, sir.
Okay. Right angle triangle. Construct right angle triangle.
Okay.
With a side 3 and 4.
Okay, sir. Side 3 and 4.
Obviously, the hypotenuse will become 5.
Okay. Yeah. Can you please try, others? Can you please try and share your screen if possible?
Yeah,
Anyone
I'll show you. Oh, achha, someone
Yes, sir.
from
Yes, sir. Sir, homework for us.
Yes,
So
that we'll check up the diagonal length and we'll check up the area.
yes, sir.
And we'll
Area
check up the
also we'll
angles
find out.
also.
Sir, and we have few queries also meanwhile, that
Yeah,
somebody was
please.
telling that
Please.
bisecting is a problem. Bisecting a line. Somebody was asking the question about that.
Shall I quickly show you bisecting a line?
Yeah, 1 second, sir. Let us do this right angle triangle.
Okay.
And then we'll do it. Teachers, if you have finished doing it, one of you can share your screen. Screen sharing option is given to everybody. If you have done it, if you have downloaded, is it possible? Or by chance, if you are using mobile for online and if you have got a system, don't worry. If you have done it, please raise your hand. That's enough. If you cannot share the screen.
Now, how do I maximize that screen? Which?
Yes. If you have downloaded Classic.
No, I have to stop my share. Is it?
No problem, sir. They can share.
Oh, okay.
He has to
How do
share.
I see that?
Yeah, sir, you can stop sharing for a moment so others can share. Again, you
yeah.
can come back.
Yeah.
You're done. Yeah. Sir, if it's difficult, no problem.
No, it's there. Stop share option is there.
Yeah.
Yes.
If any of you are using laptop and doing GeoGebra, can you please share screen, if possible?
From
See, somebody is telling I was unable to download GeoGebra basic classic app. I will tell you, please go to GeoGebra.
Yes. I'm seeing I'm seeing that triangle. Yes.
Yeah, sir, Vimala madam, it is Vimala madam has shared the screen.
Oh. See, that area is 6. See?
Yeah.
3 sides, 3, 4, and 5. Area is 6. And the 3, points A, B, C.
Yes,
Okay?
sir.
Yes. So, they got it.
Yeah.
Now,
Vimala ma'am, you want to share something? You want to say something?
No, it's okay. Fine.
You can unmute your phone, Vimala ma'am, if you want to say something. Yeah.
No, sir. I just wanted to share the screen.
Yes, ma'am. So it is wonderful. Wonderful, ma'am. Nice. You can stop sharing your screen. Yeah,
Yes,
others
Yes,
may
sir.
want to share. Yes, ma'am. Thank you. Any others want to share your screen if you are using laptop?
Yes, sir. Can I share?
Yes, ma'am. Aarti, ma'am, please. Yeah.
Yes. Can you see, sir?
Yes, ma'am. We can see.
Very good. Wonderful.
Sir, here I only asked for the perpendicular bisector doubt.
Okay.
Yeah, she only asked for bisector.
I'll show you.
Now you can ask, ma'am. You can ask once again now itself. Yeah.
Okay, okay.
Yeah.
Sir, GeoGebra.
Can I, is it possible that I do it on her screen? I don't know.
No.
No, no. Okay. So I
No,
will
sir.
share my screen now.
Yes, sir. Yes, sir. And she had a question also so that you can answer her, sir. Yes, ma'am.
Yeah,
Aarti
yeah.
ma'am, you can ask question.
Right.
Yes, sir. Basically, like when I am teaching them the perpendicular bisector for the 6th standard students,
Uh-huh.
I should tell them to take more than half so that they will draw an arc on the top side and down side,
Yes.
so that they can draw the arcs on two sides of the line. So how
Correct.
can I show that in the GeoGebra? That is my first doubt.
Yeah, yeah, yeah.
My
See,
se-
in GeoGebra, showing the arc is slightly difficult because you have to tell GeoGebra from which angle to which angle you want to show the arc.
yes, yes, okay.
Okay. And then it is not possible for us to see that they will cut each other.
Okay, okay,
Right? So in GeoGebra, what is done is you draw a circle rather than an arc.
okay,
Straight away you draw the circle. So from one point you draw a circle, from second point you draw the circle, and you get the intersection.
okay.
But if you want to make an applet for showing it in the class, not live, but a prepared applet, there first you draw the circle, get the point, and see at what angle it is, and then decide about the arc. Maybe 10 degrees here and 10 degrees there. So 20 degrees arc you can decide upon once you get the point. Okay. But straight away, see, visually we take a decision, no, where arc should be drawn.
Yes, sir.
Computer has no visual this thing to take decision as to where the arc should be.
Okay.
There are some softwares available where you can take a visual decision, right? But GeoGebra doesn't permit that. GeoGebra permits you to straight away write the equation. So here we are supposed to write the equation, but GeoGebra has provided a perpendicular bisector tool itself.
Okay.
Okay, so you may not, you tell them that this is how the perpendicular bisector is drawn, but GeoGebra has provided a tool. You can use that tool and get the perpendicular bisector. Okay, so this way it is there. If in applet you can pre-decide where the point is and then draw the arc, or take the full circle, okay, and make it faint afterwards. Okay, it's possible for you to change the properties of that circle.
Yes, sir.
So there is no way of judging by eye where arc should be drawn in GeoGebra.
So nowadays it has become a compulsion for the maths teachers, especially to use GeoGebra when they are teaching geometry. But for the younger classes, it is becoming a little difficult. Is it true, sir?
No, not at all. I'll show you some very interesting things for young children.
Correct, correct. And
You tell me which problem you are coming across. I'll solve that immediately.
yes, even I tried the pie chart. Like they have to mark the degrees in the pie chart so that the divisions they can do it clearly. So that where to keep the protractor and how to mark the degrees, that became difficult for me to teach the children using GeoGebra. So can you please help me out with that?
No, that again you will have to know in pie chart at what level are you teaching?
9th, 8th and 9th.
Nine, no problem. 9, no problem, because you can get the angle.
Okay.
Okay.
Yes.
360 degrees is divided by these angles.
Yes, sir.
And you can easily draw the line at angle. You don't have to take the compass and cut it.
Okay.
Huh?
Yes, sir. So it becomes difficult when I have to teach.
No. I'll show you how the line is drawn at an angle.
Okay, sir.
Huh? I'll just now show you.
Okay.
That particular angle, how a line is drawn. Because what you do is you start one line first x-axis.
Yes, sir.
Then let us say that you have some 20%, some object. Okay.
Yes. Okay.
So you take 20% of 360 degrees
Yes, sir.
and draw the line at that. second line at say 30%, so 20 plus 30, 50%, so 180 degrees. So like that, you draw those lines and cut that circle, that's all.
Okay. So basically, I should go on the degrees, isn't it, sir?
By degree you should, by
Thank,
degree.
thank you so much.
Yeah,
Sir,
by degree.
thank you, sir. Sorry for this interruption in between of your wonderful session. And I think Premala madam also shared her screen using mobile. She was reflecting. I'm sure many of us have tried.
Yes, sir.
To do this. You really started the very good interaction. And friends, I want to tell you, we are so proud and blessed that Dr. Barve sir is also one of the members of our smart math team. So you can always trouble him. I told him in the morning only that we'll be keep on troubling him. So you can ask a lot of questions to him in the group also after the session gets over.
And we can, so what we'll do is we can pull up these difficulties, and maybe after 3-4 days we can have one more session, no problem.
Yes, we can do that. And second thing is, it is not only about mathematics. If you see his videos later, I will share the link in our group. Wonderful things about the science. It's very simple models to teach the children. Okay, he has made exciting models, and it is on YouTube. I will share the link. That also, I'm sure we can use it straight away in the classrooms, because sir has used all the used boxes and whatever things available in our home. Okay, and it's exciting experiments. That also I'll share later. Yes, sir. You were supposed to, you were about to share another thing about 9th standard. Please continue, sir. You can share your screen. Yeah, thank you, sir. Thank you.
Now what I have to do, I have to go to GeoGebra.
Screen, sir.
Yes.
Share the screen and do, sir.
Yeah. Just a minute. Sharing the screen. Share the screen. Is it there now? Not yet, I think. Share. You're getting it?
Yes, sir. We're getting it.
Yes, sir.
It has come. Yes.
Yeah. Open. Then this PC. Then red. Then 10th math science. PPT 2. Then triangle similarity. Activity 1. See, this is the in 10th standard in triangle chapter. This is given as activity 1. Okay. The activity is like this, that in your home, under the bulb, you keep one table, okay? And then what you are supposed to do is, there you are supposed to keep a cardboard or something and see the shadow, and see that the shadow is similar to the cardboard. So we take a square cardboard and do this, right? So for that, what I do is, see, I have taken this bulb, and here I am going to show you that it is possible for you to do this stored program instead of extempo. Sometimes we find it difficult to have extempo. So the GeoGebra provides a facility that you can store the program and show it step by step. Okay, and the description of the step also will be shown. So here, let's see this. I have put a bulb here. I take some variable here. Now this height, I'm going to take 3 variables, theta, phi, and h. Let me tell you what they are. Okay. So then this is the plate I have taken. Now this plate I have taken at height from floor or table at say 1.9. Okay, and both theta and phi are 0. Now what we do is we connect this bulb with the corners as if they are the light rays. Okay, so now this is what you are going to get the shadow. So these are the light rays I am showing. So you got the shadow here. Okay, so if this is square, that is also square. Now this 3D view has a facility of seeing the thing from different angles. Okay, so for that, what you have to do is you are supposed to click this and take this view. You are seeing now from top. So this is the board which you have taken, or a plate, or a glass, and this is going to be the shadow. Supposing this is a blue colored glass, then you get a blue colored square here. Okay, you can see the other thing, the third thing, and a general view. Okay, now this is what is given to them, but I have added few things here. That is, what I do is I show them that if I change this angle theta, see what happens. Now if I see that view, see, we had a square plate that when inclined and seen from top, it becomes a rectangle. And its shadow is becoming a trapezium. Okay. Now let us ask them why this is a trapezium when this is a rectangle right now. Okay. Then in the other view, this will be clear to you. See, this point has moved up. Okay. So it is closer to the bulb now. And therefore it will cast a shadow which will be longer. Now this is away from bulb. So it will cast a lesser length shadow. So we show them again. This length has increased, this length has reduced. And that is why it has become a trapezium, right? Whereas if I change this phi, see what happens. Now this becomes a kite. Okay? So shadow of a square can be kite also. Now here again we come back and show them the other view. Okay. See now, this corner has moved down. So this will be closer to the center and this will be farther to the center, and that is why this has become a kite. So this is the advantage of GeoGebra. Okay. I don't know how many students will do the activity of the plate and bulb and at home, right? Normally they will read the book and forget about it. Okay? But it is possible for you to show these things and relate this to optics. Okay? Yes, any question on this? Hello, I'm not getting any response.
Yeah,
No,
yeah.
How did you get that bulb up, option?
Yes, please.
You thought that bulb will be up. Can you show, sir? How did you get that bulb up, sir? I got this grid.
Yes, yes, yes. I'll show you. I'll show you. Just a minute. Where is that bulb? Okay, in the other view, I can see that bulb. This is the bulb. See, you have got X, Y, Z axis, no? This RGB is the convention in 3D. Okay. Now, this bulb I have put here at H0 is equal to 5. Okay. So this has coordinates of 0, 0, 5. You see here, 0, 0, 5.
Okay.
So every coordinate will have this is 1, 1, 2.7. And if I cut this here, now you'll see that all these points are at 1.9. Right. Okay.
Okay. Sir.
And they are symmetrically placed. See, this is 1, 1. This is minus 1, 1. Minus, plus, minus. Okay. This way. And here the shadow automatically comes to be symmetrical. So this is how it's possible for you to take care of it. And then when students get quite tired, I have got something for them. GeoGebra.
I'm sure, sir, all the teachers are in awe of GeoGebra and Vasant sir.
because probably they did not get into it, you know.
Huh, sir. I think the amount of work you have explored in GeoGebra is immense.
Yeah. See, and in fact, this particular GeoGebra was brought to notice of my notice by one teacher from Jharkhand.
Okay.
See? Yeah. See, initially I used to work in Java and C language and put up a lot of things on web. Okay. So it so happened that teacher saw my blog and he contacted me on mail that he wants to do a work like me. Okay. Sanjay Gulati is the name of the teacher. He had put up a lot of material on the web also. Okay. So then I said that I am doing this in Java.
Yes.
So I will, he said, I don't know Java. I said, I'll teach you. Okay. I was in US, he was in Jharkhand. Okay. So we started interacting every day on Skype. Okay. And he picked up a little bit of Java. And then one day he said, no, I stopped learning Java. Okay. I thought he's tired, you know. He said, no, sir, I'm not tired. I have found one magical software.
Okay.
You please try it. And then, I started using it and then I stopped using C and Java and all those things.
Yes, because the better tool you got, I think so.
Yeah, Sanjay Gulati is now a state trainer in Jharkhand.
Okay, sir.
I know sir, Sanjay Gulati sir. We had a wonderful interaction also on Facebook earlier. But only thing is I didn't explore the opportunity to learn from him actually because of this one. It is very nice. Nice to see. Nice to hear his name.
This is I'm talking about, I think, 2008.
Okay, sir. So now what sir is showing is a very beautiful depiction how we can make GeoGebra interesting for, I think, not only school students, college students, for adults, teachers, everybody. So I think we'll enjoy this and then we'll come back again to the interaction.
Yeah, when there is a long interaction, say, for example, one day I had about 3-hour interaction with NIT Arunachal Pradesh students. Okay. So after an hour or so, I said, all right, you are tired? No. So let us do some exercise. So I asked them to come out of the desk and, stand clear of each other. Okay. And then I said, okay, let us do it. So they did this position. Then you got, make them circle. And immediately the equation is also here, available here, x square plus y square is equal to r square. And then we have got hyperbola, 4 of them.
Wow.
See the twinkling of the eye also.
Dancing mathematics.
Okay, right? Whenever the arms are there, the fellows are looking to each other, And whenever the arms are away, they are looking away from each other. Okay? So all these things, you can make it very interesting.
Indeed.
Mod, minus mod, plus mod, drooping line, rising line, cot, minus cot, tan, tan x, minus cos x, minus sin x, and sin x. And some of them really, they, tried these poses and enjoyed. Okay. So this is how it's possible for you to make these things. And one first international yoga day, I did something. I'll show you. This was put up on the. Now this I'll throw a challenge to the teachers. Yeah, these two are very, very simple. Just by reflection, you can do it. Okay, but let us see how this is done.
Okay, sir.
Oh,
Oh,
wow.
so interesting.
I'm sure all the teachers are in awe of these usage of the Geogebra tool.
And I think I have used these 36 dots. I mean 33. We've got 33 those vertebrae, no?
Very nice.
Perfect bending of that. And when he bends down, the seat going behind. Seat going behind to balance. This was put up on first International Yoga Day. And if you are in the primary classes, there again you can entertain them. Let me see whether I have that. Or one more interesting thing I would show you is, you got this discrimination, but I don't remember the name I have given.
Yes, sir. I think by the time teachers, I would request you, please keep your questions ready. After this, we'll take up the questions.
Yes.
And then plan how to go ahead.
Yeah. 1 minute.
Any queries, kindly unmute yourself and we can ask, sir.
You can also make GIFs out of this.
Then we'll come to know how it will. We need to explore.
Oh, Mamta ma'am, you need to explore to get more questions, right?
Yes, ma'am.
Okay.
I'm doing that only right now.
No worries. We'll take some time to explore. No worries.
Yes.
So if we can stop sharing, we'll just have just 5 minutes more interaction with all.
Yes. No problem.
Yes, sir.
Where do I do it? Stop share.
Yes. So, friends, just I want to share something because you all are there and sir is also here. Can you hear me?
Yes, sir. Yes, sir.
I want video. Okay. So, can you hear me?
Yes,
Okay.
sir.
Yeah. Okay. So, because sir is there and we all are there, it's such a nice opportunity. Now, what we thought, sir, after interacting with this, some of the people here might be already using GeoGebra and exploring new possibilities and using effectively in the classrooms. And some of us are novices. Now we started and you created that curiosity and interest in us. And as Mamata ma'am said, to ask any question first, we have to explore. But one thing is we all are mesmerized for sure today because of seeing the possibilities and using it effectively in the classroom. We all are really, it is a wonderful thing. So what we are planning, sir, now, if it is possible for you, can we have a small course with you, sir? Probably some 5 hours or 4 hours where you can teach us. You can teach us so that we can effectively use it in the classroom and get back to you with our queries.
You draft what you want exactly. I mean, so
that is what. Yes, sir. If you can teach all of us some examples of 4 hours or 5 hours whenever you get time.
Correct.
So, and we all will come. Do you agree with me, all of you?
Yes,
can
sir.
We learn? Can we learn?
Yes, sir. Yes, sir.
Yes, sir, definitely.
So some of you, whoever is interested, we will have a convenient time. We will request sir also to give the convenient time. Right, sir? So probably to start with some 3 hours of basic introduction. Sir, my request is if you give us some examples and make us to do hands-on. So we will practice and we will implement in the classroom and get back to you with our questions also.
So one example for all the classes, means till 10th.
Yeah, if we use it.
But it will be better whoever is doing the GeoGebra right now and they found difficulty, let us post those only.
Yes. That is
That
also
will be
fine.
better. Many of you are using it and they have found some difficulties.
Yeah.
So
that is fine, sir. Today,
as well as others.
Yes. So today what sir says is, if any of you are using GeoGebra already, if you have got any questions, please ask so that will be clarified today. And remaining, if you are using now, start practicing now, let us have a convenient some 3 hours of time so that every 1 hour sir will teach us something. We will implement in the classroom, come out with our questions. So that way we can learn better and implement in the classroom also. So, so to stage 1 is, if you are already using any of you, if you have got any questions, please ask so that we'll have another 5 minutes and we'll have the discussion.
And one module I want to show you.
Yes, sir. Yes, sir. Please, sir. Please, sir. Please. Yeah.
Should I start that?
Yes, sir.
Yes, sir. Yes, sir. Please.
Okay. Now I have to share the screen. Okay, where is it? Share the screen. Okay. Share. Are you seeing it?
Yeah. Yes, sir. Yes, sir.
Yes, sir. Yes.
There
Wow.
is a child here, and this I was doing in one of the schools. Okay, so both husband and wife, they were teachers, and the daughter was also in the school. So everybody knew these people, right? So now what I tell that this is a house in which these two they are sitting comfortably, and the child is playing in the garden. Okay. Then after some time, suddenly mother remembers that she has to do some homework. So mother is trying to come out of this house, but she is bound here. Lakshman Resha.
Nice, sir. Very nice.
Whereas then she asks the gentleman, and he goes out. No problem for him. Then normally, for higher classes, I ask them who stood first last year, and normally girls are there. Is it not? The first in the class, normally a lady. So they say they will get the job and you will be at home, so you will be bound. Okay. So now what I do is I make a small change here. Okay. This F I change to M. Sorry. What has happened? I've changed this to M now. Right? Now this field should get bound. Why not moving? See, this lady is coming out now. See, he is bound now. And please note that this is based on 6th class concept. Can you tell me what is that concept? In 6th class, we are teaching them convex and concave polygon.
Yes, sir.
Yes.
Okay.
Yes, sir. Yes, sir.
Is it about the diagonal?
This one?
Diagonal, sir?
The diagonal?
If we join the consecutive opposite side points, we get diagonal. If that diagonal is drawn, if it comes inside the figure, we call it as convex polygon.
Yes, correct. But here, what has happened is these point, see this point,
Mm.
I have included as point on polygon.
Okay.
And I have said that polygon must be convex.
Okay.
So this point gets eliminated.
Yes.
But when I move this point out,
Mm.
as soon as it touches this line
Mm.
and tries to move out,
Little of
it becomes part of the polygon.
logic through close of.
And this point not being included in the polygon, see here the definition is here.
Mm.
See this HIQRM. Okay, this is the definition of that polygon. I'll do one thing, I'll bring it here. See this HIQRM. Okay, is this particular polygon. Now this one, if I move inside, then it gets eliminated, because otherwise it will become a concave polygon. You follow me? If
Yes,
I
sir.
am having it, this is convex. But if I remain connected like this, it will become concave. So function does not allow this polygon to become concave. Okay. I mean, these children may not understand, but you can make them, some fun. See now this point again will become free inside, bound outside, bound outside, bound outside. And I change this, that F I removed and I put M. So this now point becomes free. This is no more a part of that polygon. It can go anywhere. Same thing I have done here also. This trampoline or this jhula, what I have done is there is some point here at the feet of this young lady. So as soon as that touches that line, it becomes part of that. And it shows such a beautiful thing that there is a spring kept there. Actually, if I want to make this as a spring and make this, the function will be very, very complicated, because it will be a non-linear spring. Okay. So by this function, see here, this is the function, convex hull. So just by making use of this particular function which is available, there are so many beautiful functions available in GeoGebra. There's one more is the traveling salesman. Traveling salesman problem is like this, that there are some cities given, the geometry of that, and then salesman must visit all the cities only once, and you have to trace a minimum path. That problem is very, very difficult, but GeoGebra has provided a built-in function for that. Okay? So within seconds you can get the thing. Then you have if you have number of points, then you can you have the optimum line through that. All these functions are available. So you go on exploring this particular thing. See, if you just put this question mark here, you just click this question mark, you will see the list of commands here. And try to understand these commands. For each command, you have got description available on the net. There's an entire, module where all these commands are explained. And then try this. Try each of these commands, right? So I have done about 100, 200 commands. I already know what they are, and I'm using those. And making this animation is very simple. Take some variable, and then you right click and say animate. Okay, and the animation starts. And this button, if you click, the animation stops. Okay, so you've got a lot of things. I mean, even financial functions are available. That is, if you buy a house, what would be the monthly payment to be made, and all those things. All such functions are also available. Okay. So financial functions are there. statistics functions are there, vectors are there. See, here you have got the entire list. You see 3D, algebra, chart, conic, discrete mathematics, then financial, calculus, everything, probability, vector, right? I could solve each and every problem of 10th standard here. I tried 11th, 12th also. You have got built-in function for integration. Is a wonderful thing. And it shows graph of that integration function. And if you put the definite integral, then it shows you the colored zone which comes under that particular curve. So I've tried many functions from 12th standard. All of them work very well there. No problem. Then optimization, that is, linear programming you have. Some problems in 11th and 12th standard. So there, one single line can draw that particular diagram and colored beautiful diagram, which would take about half an hour for you to do it on piece of paper. Here you in one line, you get that particular thing and make it very interesting, colorful. So none of the problems of mechanics, will be difficult with this. You can show them beautifully well. Okay. And I tried first year engineering problems also because it supports the linear differential equations also. So most of the first year engineering problems also I could do very well. The engineering drawing problems can be shown very nicely in GeoGebra, step by step. See, so it's a wonderful thing. You please explore that thing, right? And make a pool of the material used. I'm ready to share my material with you, okay? And make life easy for teachers and students, and let them not get scared of mathematics. That is the thing. I think Kerala and Tamil Nadu, they are, promoting this GeoGebra to a great extent in their syllabus itself. Maharashtra government has made a mention and trained some teachers, but somehow it has not picked up because probably teacher wants to go in that track, whatever they were going through. Okay? But if all of you can take some interest and propagate this, as Mr. Sanjay Gulati is doing there in Jharkhand, he has become a state trainer there. So, just see whether we can take ahead this particular thing. Not only this, any other software also. There is one more software, Logo, which I'd like to show you sometime. Okay? That is also a wonderful, and I have tried that from 3rd standard students. And they like it, and they learn a lot of things through that. And that software is such that it takes you right from very basic to advanced features of programming. That is, it has a 3D modeling and recursion. Recursion is supposed to be quite difficult in programming. It supports the recursion also. Okay? So you have a lot of things available. So just have a look whether it's possible for you to do it. I'm ready to help. Okay? I'm a happily retired person. I don't need any returns from anybody. Okay? So you are all welcome to have your doubts, difficulties. My email address I'm ready to share. It is vasantbarve@gmail.com. Very, very simple address because I did it, right in the beginning. So there was no problem in getting my name. See, it is like this.
Sir.
vasantbarve@gmail.com. Yeah.
Sir, thank you very much.
Yes, please. You can take down this and you can send me mail of any difficulty and I'll solve it and send it to you.
Sir, thank you very much.
You are welcome. Should I stop sharing?
Yes, sir. Yes, sir. You can, sir. Sir, thank you very much. In fact, we are all really mesmerized to see such a good presentation with all your experience, sir. So I would request
one round of applause from all the participants for Dr. Barve sir. Yeah, thank you everyone. See, sir, actually, I was totally engrossed into the screen what you were throwing on the projector here at our office. And in fact, I will tell you, sir, GeoGebra, even though it was invented by Mr. Marcus during 2002, the actual potential of GeoGebra has been witnessed today only. But of course, he started all this for his master's program. But I am sure, I think you have explored far beyond his vision itself. So, and another thing what I have observed, sir, in you is even at this age, you are having so much of enthusiasm. You are actually making us really shy. And we will be really happy.
No, I want to promote. I want you to promote. not shy. I want to take you ahead of me, you know.
No, sir, we definitely
every next generation is superior to the previous generation by Darwin's law.
We would like to definitely, step on your footsteps now. The way you have used your visualization, your mathematical skills, mathematical knowledge, and using the application is really exemplary, sir. In fact, we have seen several applications till now, not only GeoGebra, many other applications, but the way it is used is actually going to make all the difference.
Correct.
Okay, so
that is the skill of the teacher.
My request to all the teachers here also is that it is not that we need to know programming language or programming to use this GeoGebra application. You can see what exactly and which exactly you want to cover as per the requirement of the syllabus and as per your need. You can straight away start using the application as it is. And several tools and drivers are already provided. Application library is exhaustive. And only if need be, you can get into the programming aspects. Otherwise, majority of it is already being seen in the library, at least as far as I have seen it just now. Of course, I also have to explore it more before I talk like this. But with the way sir has used the application, I am very sure library is quite exhaustive. So I really thank everyone here for showing so good interest in participating for this particular session. And I really thank Barve sir because we forced him to go and buy a dongle today again, even though there were a lot of other power related issues at his place. So thank you very much, sir.
Yes. You are welcome. You are welcome. All teachers should start using this.
Yes.
And if any difficulty, pose it to me. Within 2-3 days, I will revert to them.
Sure, sir. And as VSR sir was pointing, we would definitely try to make a session through Barve sir and see that GeoGebra is used properly at different places for a specific purpose.
Yeah.
So we will define that purpose and then we will definitely revert back to you, sir.
Correct. And a lot of material from 6th standard to 12th standard is ready with me. I have 1 or 2 applications even for KG students.
Yes, sir. And whoever is interested in the certificate, please email us. Definitely the certificates will reach you. Name and your name and school name also. Please mail it to us so that the certificates will reach you by email. So thank you, everyone.
Does that certificate carry my name?
Yes, sir.
Does that certificate include my name?
Definitely, yes, sir. Without that certificate will be invalid, sir.
Okay. No, I would suggest you that put the email address there.
No. Sir, Barve sir, not only your name, actually, one certificate will reach you also, right, sir? With your name. So,
No.
with all the participants thanking you. Yeah.
Put the email address.
Yes, sir.
So that anybody at any time can contact me.
True. So it will reach everybody because for all the sessions, sir, whomever we are attending, as a token of remembrance or gratitude, we issue a certificate for because they've shown a lot of interest and they've attended their time. and naturally it carries all the details of this thing that might be useful for their professional growth also later on. Yeah, for that purpose.
Let it be added to their cap, feather cap.
Yes, sir. Yes, sir. Yes, sir. So we should. So thank you all. Thank you so much, sir. Thank you so much, sir. We keep on troubling you again very frequently. Thank you so much, sir. Namaste. Thank you. Namaste, sir. Namaste all. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Right.
Thank you.
Thank you.